Hello and welcome to this advanced physics presentation on displacement, velocity, and time by Andrew Montgomery and Faith Williams.
First off, what is displacement? Well, displacement is a vector quantity, meaning it is measured with both magnitude and direction, and is also described with an arrow or a plus or minus sign. Displacement is measured in a straight line from where you start to where you finish. It can be either negative or positive. These are some examples of displacement. For instance, you start on a track and run an entire lap around. Your displacement would be 0 because you end up exactly where you started. Let's say you're walking from point A to point B. Your displacement is 4. You walk from point A to point B to point C. Your displacement is 5. If you walk from point A to point B to point C to point D, your displacement is 4.
Next, how to find change in displacement and examples of displacement versus time graphs. The change in displacement can be found using the starting displacement and the final displacement, using the equation change in d equals d2 minus d1. First, what is the change in displacement between 2 and 8 minutes on this displacement versus time graph? First, we're going to use our equation, the change in d equals d2 minus d1, which you will substitute in -1 and 2, giving you -3 blocks. Next, what is the change in displacement in the first 5 seconds on this displacement versus time graph? You're going to start with your equation once more, the change in d equals d2 minus d1, in which you will sub in 5 minus 0, giving you 5 meters for your displacement.
So, how can we use displacement? Well, the rate of change over time in displacement is equal to velocity. So, velocity is equal to d over t, where v is velocity, d is displacement, and t is time. Here are the formulas in other written ways. Velocity is also a vector quantity, which means it can be in a positive or negative direction. The positive direction is often referred to as north, east, right, or up, and the negative direction is referred to as south, west, left, or down.
Next, the displacement time graphs with constant velocity. These graphs have constant velocity. Since displacement is directly related to time, the slope of the graph is equal to velocity. The y-intercept is equal to the starting position, or d1. The equation for a line is y equals mx plus b. So in the terms of displacement, velocity, and time, this equation will change to d equals vt plus d1.
Here are some examples of displacement time graphs in real life. So, a car starts from home and drives at a constant 15 meters per second due north. What is the equation and graph for the motion of the car? Well, first we have to write the givens. We know that d1 is 0 since the car starts from home, and velocity is positive 15 meters per second because it is traveling due north. Then you have to write the equation leaving the x, which is displacement, and y, which is time, variables. So in the equation that you learned, displacement is equal to vt plus d1. Displacement is equal to 15t plus 0. Then you can draw the graph. The equation being d equals 15t, that gives you the graph right here, where displacement is on the y-axis and time is on the x-axis. giving you a straight line, which would be your velocity.
I just wanted to say a big thank you for watching, and I hope you enjoyed the video.
Finally, we'd like to give credit to the programs that made this video possible. First, credit to Microsoft PowerPoint, which was used to create the slideshow. It can be downloaded on the PC or used through Office 365. We'd also like to give credit to Zoom, which we use to screen record the presentation. It can be downloaded on almost any device.